Hello everyone, welcome to my channel Boring Physics. The previous two classes we have completed the work power energy, and today we're going to discuss about the numericals of work power and energy. So first we can do one numerical. Question number 1. A weightlifter lifted a load of 200 kg F to a height of 2.5 meters in 5 seconds. Calculate number 1, the work done, the work done, and number 2, the power developed. The power developed by him. Okay, and here G equal to 10 Newton per kg. Okay, so let's see the question. A weightlifter lifted a load of 200 kgf. So 200 kgf, the given things we have to write first, and the height is given 2.5 meter, and in 5 seconds the time is also given that the 5 seconds. So let's see. Given, what are the given things? Load is given 200 kgf. Load 200 kgf, so you have to convert into the Newton. So you can say 200 into 10, so we'll get 2000 Newton. Next is given height h is equal to 2.5 meter, 2.5 meter, and they have given the time t equal to 5 seconds. So we have to calculate the work done. Work done is w equal to, we can say that, force into displacement. Force into displacement here in the sense of height, and the load is already one type of force only, so we can say 2000 into the height is 2.5 meter, so we can say that it will come 5000. SI unit is of work is joule, so 5000 joule. Next one, we have to calculate the power equal to, you know, that work done by time. So work is already given 5000 divided by the time is 5 seconds. So we can say, if we cancel 1000, so the power should become 1000 watt. Please keep it in your mind, power is 1000 watt and the work done is 5000 joule. If any problem, you can ask me in the comment section, I'll give you the reply. Okay, so this is the first question we have done. So here move on to the second question. Let's start first the second question. Question number 2. This one we can try. Let's see. A water a water pump raises A water pump raises 50 liter 50 liter of water through a height of 25 meter in 5 seconds. Calculate the power of the pump required. Pump. Calculate the power of the pump required. Here, two, three things we need to do. And G, obviously, they have given only 10 Newton per kg. 10 Newton per kg. And the second things, they have given the density of water. Density of water equal to 1000 kg per meter cube. 1000 kg per meter cube. Okay. So now the first we have to calculate here power. So power means we know that W by T. So here W, when we have to calculate, we know that power, when we have to calculate power equal to W by T. So here basically W, we can calculate force into displacement or otherwise the mgh. So here we have to use the formula mgh. So mass of water we need G already given 10 and H is also given 25 meter. Okay. So first of all we have to calculate the mgh. So mass of the water we need. So here they have already given volume of water. Volume of water has given how much? 50 liter. 50 liter means we can say that 50 into 10 to the power minus 3 meter cube. And we know that mass equal to, or we can say the density equal to, we know mass per unit volume, right? So mass equal to, we can easily calculate density into volume. So density is 1000 into the volume is how much? This one. So we can say 50 into 10 to the power minus 3. So this one is 10 to the power 3 and this one is 10 to the power minus 3. It will be cancelled out. So mass we are getting 50 kg only. So now we are coming to the to calculate the power. Mass we have got it, that is 50 kg, and G we are having 10, and height is also given 25 meter. So write first 25 meter divided by the T. T is 5. 5. So what basically we are getting? 550. So 10. 10 into 10, 100 into 25. So we are getting basically, sorry, this one. 10 into 10, 100 into 25. So we are getting 2500. So obviously it should become in watt. So power is 2500 watt. This only the second question we have done. So let's see another one question also we can try. Question number 3. One comparison question we can do, because this type of question can come also in the exam. Okay, compare the work done between the two persons. Okay, compare the power also we can. So let's see, this one we can do. Given that a man raises a box of mass 50 kg, 50 kg to a height of 2 meter in 20 seconds, while another man while another man raises the same box to the same height to the same height in 50 seconds. Question 1. Compare work done. Number 2. Power. Okay, developed by them. And number 2, we have to calculate work done, work done, and power developed by each man, developed by each man, and this one developed by them, developed by them. Okay, so let's see that the first one we can calculate. So here we can give, suppose this one is man 1 and this one we can say man 2. Okay, man 1, mass is same for both, mass 50 kg and height is 2 meter. So height h equal to 2 meter, time is given 20 seconds. Man 2, mass m is given same only 50 kg and height also same 2 meter, and the time period t equal to is given, t is given 50 seconds. Do one thing, mass to this one we are writing for man 1 m1 h1 t1, this is m2 h2 t2. Okay, now we have to calculate the work done for the first man, w1 equal to, we can say w equal to force into displacement, right? Force equal to what? Mass into acceleration. So mass is given, force equal to force into the displacement. So we can say force is mass into acceleration due to gravity into the displacement, that is height will take. So mass is 50 kg into 10 into s is 2 meter. So what we'll get, 50 into 10, 500 into 2, that is 1000. This is the 1000. So work done, what we are getting, 1000 joule for the man 1. Now man 2 we are going to calculate the work done. So we can say F into S. Here also both are same. F is mass into acceleration. Acceleration means G only in S. S means it should be the height only. So mass we are having the same, 50 into 10 into the height is also 2. So ultimately we are getting this one also 1000 joule. So the second question, first one we have done earlier. So work done we have calculated. Now we have to calculate the power. For the first man it is taking time t1, and second man it is taking the time t2. So let's see the power. Power here it will be p1. We know that w1 by p1. So w1 already we know that 1000 divided by t1 is 20. So we'll get that it will become 50 watt. Right, the same way if we want to calculate the p2, we can say w2 by t2. So w2 already we have calculated, that is the 1000 divided by t2 is 50. So we'll get that 20 watt. Now the question, whenever we have to calculate, we are coming, the power part we have done, the calculate for each man we have done. Now we have to compare it. Let's see the comparison. So let's see the comparison. Compare work done by the first man is to work done by the second man, but here both are same, so we have to do 1000 is to 1000. So we'll get 1 is to 1. Another one is power, we have to calculate p1 is to p2 for the two men. So we can say that power we have got it, one is 50 and another one is 20. So if we do that the calculation, we can say 5 is to 2. So this only the comparison we can easily calculate. Both are very easy question. This type of question can come in the ICSC. So all of you do other sums also from any book, whichever the whatever the book you are using, from that book you can use it. And if any problem, let me know in the comment section, I'll give you the answer. The next question we are going to do, suppose the question number 4. Question number 4, suppose we are doing a man of mass 50 kg climbs up a ladder of of height 10 meters. Calculate number 1, the work done by the man, the work done by the man, and number 2, the increase in his potential energy. The increase in his potential energy. Okay, now let's see first how we have to do. So first of all we have to calculate the work done. So we can write that the given things here. Here they have mentioned that g equal to 9.8 meter per second square. Okay, so first we have to calculate the work. So the work we can say that as w equal to, we know, force into the displacement. Here force is given. Force means we know that mass into acceleration. Here it should be acceleration due to gravity into s is the distance, so as a height. So mass is given how much, 50, g is given 9.8, and the height is given 10. So we can say that it will come 50 into 10, 500 into 9.8. So we can say 4900. Another one. After one point, so 4900 joule, we can easily say. Next one, increase in his potential energy. Increase in increase in his potential energy, we have to calculate. So here basically when we have to calculate the increase in his potential energy from the ground to a ladder height is 10 meter. So potential energy formula also we know that mg into h1 minus h2. So h1 is the highest point or the height which one is given, and h2 here nothing is given, so obviously it should be the ground, means it should be 0. So basically the answer will become same only. Mass is 50 into 9.8 into h1 is 10 minus 0. So we'll get same answer, 4900 joule. Keep that in your mind, the potential energy. Four question we have done. Next one we can start. Let's say another one question. This type of question mostly comes in the exam. Which one we are going to do? Number 5. Mostly this type of question is coming in the exam. Question is, calculate the decrease in kinetic energy. Decrease in kinetic energy of a moving body, of a moving body if its velocity, if its velocity reduces to half of the initial velocity. Velocity. So first we have to calculate the decrease in kinetic energy of the moving body if its velocity reduces to half. So suppose the body have mass is m, velocity v, mass m, velocity v. So we can say that the kinetic energy will become half m v square. No problem this one. Now the same body, when the velocity, this is the initial, this part is the initial part, we can easily say. Now the final part, velocity reduces to half, mass will be same. So the final part, mass m, but the velocity reduces to half, means v by 2. So we can calculate the kinetic energy final. It will become half into m into v square. V square means v by 2 whole square. This one is, many students are doing that the wrong. Okay, in this position. So we can say that half into m into v square by 4. Okay. Now this is the initial kinetic energy and this one is the final kinetic energy. Now if we want to calculate how much what they have said, calculate the decrease in kinetic energy. Now decrease in kinetic energy we need to calculate. Let's see, decrease in kinetic energy, what we can say. At first it was half m v square. Now we are having half m v square by 4. So what we can do, we can take first half m v square common. We are getting 1 minus 1 by 4. So we can say that half m v square into 3 by 4. So basically we can say that 3 fourth 3 fourth of the 3 fourth into half m v square. Half m v square was the initial kinetic energy. So we can say that 3 fourth of the initial value or the initial kinetic energy. Okay, so this type of question is very very important. It is coming to the exam also. Okay, so everyone please do this type of questions. Okay, another one question also we can try. Let's see, number 6 we are going to do. Question is given, how much work is needed, how much work is needed to be done, to be done on a ball of mass 50 gram to give to give it a momentum of 5 kg meter per second. Okay, how much work is needed to be done on a ball of mass 50 gram to give a momentum of 5 kg meter per second. Okay, so keep it in your mind, this type of question also can come. So what is given, first we have to write, given m equal to 50 gram and they have given the momentum p equal to mv equal to given 5 kg per, so 5 kg meter per second. So first we have to calculate what, we have to calculate the v, then we can calculate the with the respect to the half mv square. So here v equal to, so here they have given mv equal to 5 kg. So v equal to, we can say 5 by m, mass is given 50 gram, so you have to convert into kg. So 50 by 1000, 1 cancel, so basically we are getting 5 by 100, 5 by 100, this much of kg. So here basically 5 by 100 will get equal to, what we can say, 5 into 100 by 5. So we are getting 100 meter per second. How much work is needed? So, and here they have given that the momentum. So we can say that work obviously is equal to the energy also. So we can calculate first the energy, how much we need to do that much work. Half m v square. So we can say half mass is given how much, that is 5 by 100 into v square. V equal to 100 they have given, so 100 whole square we can say. So half into 5 by 100 into 100 into 100. So 100 we can cancel, 2 it will become 50. So 50 into 5 we can say 250 joule. That is also another one numerical we have done. So so many numericals we are having also this type. Okay, so you can try. If any problem, you can let me know, you can ask in the comment section any type of question. Okay, let's see another one, the last one we can try. Number 7. This type of questions only coming in the exam. Okay, so keep it in your mind. They have given one question: a ball of mass 0.5 kg slows down from a speed of 5 meter per second to that 3 meter per second. Calculate the change in kinetic energy, change in kinetic energy of the ball. Calculate the change in kinetic energy of the ball. So the kinetic energy first we have to calculate. Let's see what is given. Mass is given m equal to 0.5 kg. V1 is given 5 meter per second, and here V2 is given 3 meter per second. We have to calculate the change in kinetic energy. Keep it in your mind, change in kinetic energy. So we can say that the change in kinetic energy equal to, we can say, half m v1 square minus half m v2 square. So half m we can take common, we can say v1 square minus v2 square. Mass value already given, put it 0.5. V1 is given 5 meter, so it should be 5 square minus 3 square. So what we can say, half into 0.5 into 5 square is 25 minus 9, so it will become 16. So half into 0.5 into 16, so 2 if you cancel it will become 8. 8 into 0.5 will get basically 4. So it should be 4 joule decrease. 4 joule decrease. Keep it in your mind. This type of question you have to do. You have to practice also. Do practice more numericals from the chapter. Please subscribe the channel Boring Physics. Thank you. The next topic we'll have on machine will start in the next class. Please do the revision always, do the work properly, do the numericals